Okay, welcome back to our review for the Unit 4 lecture exam. And now we want to review the first of 4 lessons on electricity and magnetism. So the first one was entitled Electrostatics, and now you should recognize what that device is that that lady is putting her hand on, and then you should also recognize the reason why her hair is standing on end. So if you have any understanding of electrostatics, you should recognize that as a Van de Graaff generator, and you should be able to explain how the Van de Graaff generator works, and you should explain why her hair is doing that. So this is going to be from chapter number 22 from your textbook. And then also, if you've got time, it's a good idea to do these crash course episodes because they will help to expand your knowledge of this. And then I know that you don't have anything else better to do, so also do the physics fundamental stuff. And then for good measure, go ahead and do the physics in motion. So lots of videos that you can be watching that will help you to understand this material. Okay, and then the PhET videos as well, or the PhET simulations. Okay, so remember, you don't need to know anything about gravity. So that column over there, that pink column, the orange column, do not worry about that column. It's not going to be on the exam, okay? Don't need to know about gravity. But you do need to know about the column that is in green. So make sure you know what electric charge is. So let's make up a list up here of the various terms that you should know. So you should know what the letter Q is. So that stands for electric charge. And then the official metric unit for it is going to be the coulomb. Make sure and know that. Okay, then the electric charge is going to be what causes the electrostatic force. So opposite electrical charges are going to attract, like electrical charges are going to repel. All right, what does conservation of electric charge mean? You should know that. It means you can't create or destroy electrical charges. Now what you can do is separate them. So if you've got an atom, you can pull those electrons off. So you've separated the electrical charges, but you can't just take this electrical charge and throw it away. You can't destroy it. It always exists. Okay, then we've got the force of electricity. So we're going to say F for force, and then then put an E for the force of electricity, and then any force is going to have the units of newtons, named after Sir Isaac Newton. Another term that we need to introduce is the letter R. So the letter R is distance, and then its official metric unit is going to be the meter. So here's our formula for the force of electricity. So you got to know this. I will give it to you on the exam, but you've got to know how it works. So that the force of electricity is going to be proportional to Q1, Q2, and then divided by R squared. And notice that I used a proportion instead of an equal sign because I don't care about the K. So that K is a constant of the universe, and I don't care about it. It's not going to be on the exam. You don't need to know that constant. Now, I could give you a conceptual question, though, that will test your knowledge of this formula. So I could say that if I triple charge number 1, what does that do to the force? Okay, if I triple it, whatever I do to this side, I have to do this side over here. So it would increase the force by 3 times. I could say, what would happen if I triple this one and I this one gets 5 times bigger. So then what would be the new force? Now notice that this is not Q1 plus Q2, it's Q1 times Q2. So it's going to be 3 times 5, and then my answer is going to be 15. Now I could even, so let's make it even worse, I could say what would happen if I do this and I do this and I double my R. Then what happens? Well, you might be tempted to say that my answer is 15 divided by 2, which I'm going to give you partial credit for, but what did you forget to do? You forgot to square it. So 2 squared is going to be 4, so that means that my total answer over here would be 15 divided by 4. So times the original force. Okay, so those are kinds of questions I would want you to be able to answer on the exam. So again, here's a sample question that shows your ability to use this equation. All right, let's take a break, and when we come back, we'll talk about the electric field.